This recording will cover section 3.4. So we'll begin by listing out the identities that we've learned so far in section 3.1 through 3.3. I have encouraged students to keep a list. Okay, so number one, we learned about the reciprocal identities. And you can go back through 3.1 through 3.3 to write down the identities, but these are just the groups. So number one was reciprocal. Number two was tan cotan. Number three, we had the Pythagorean identities. Number four, odd even identities. Number five, sum and difference for cosine. Number six, cofunction. And then today we're going to learn four more to complete the list. So altogether, there'll be 10 groups of identities. These become tools in our toolbox. We use identities to help us simplify expressions, find the exact value of trig functions that are not on the unit circle, prove identities are true, and then later solve trigonometric equations. So the sum and difference for sine is going to be number 7. Okay. And we had a little jingle to help us remember the sum and difference for cosine. We'll also have one for the sum and difference identity for sine. So this one is number 7. Okay, so for cosine, we had, it was cosine, change the sign, sine. So I said it was cosine, sine. We insert first angle, second angle, first angle, second angle. For sine starts with an S. Remember, this is the sandwich. Because it goes sine, cosine, sine. Oops. So the sine is the bread, cosine is the filling. Okay. So my study partner in trig would always repeat sine, cosine, sine. Cosine, sine. Use a method that will help you remember these identities. And these are the identities for sum and difference for sine and cosine. Okay. The suggestion that they have here in the notes is to write out the identities in the general form every time you use them. Okay, so following the steps that we learned yesterday, we want to start by rewriting the given angle as the sum or difference of two unit circle angles. So 15 degrees is equivalent to 60 degrees minus 45 degrees. You must pick two angles whose sum or difference is the given angle, and these angles have to be on the unit circle. Okay, so UC for unit circle. Step 2, apply the identity. So for the sine sandwich, we go sine, cosine, sine. It's our sandwich. And notice the plus or minus sign stays the same. For the cosine identity, it's cosine, change the sign, sine. So for the cosine identity, you do have to change the plus or minus sign. For the sine identity, you do not. Okay, then you insert first, second, first, second. Okay. So let's get warmed up here by applying our unit circle knowledge, starting with Hector. Hector, what is sine of 60 degrees?
Um, um, not sure, Professor.
So 60, that's the short leg, long leg group. Sine is the y coordinate, so it's going to be long leg. What's the length of long leg?
Oh, okay, so it will be square 3/2 then.
That's right. Very good. And Genesis, how about cosine of 45 degrees?
√2/2.
That's right. Let's go to Jimmy. Cosine of 60 degrees. Okay, not hearing from Jimmy. Let's go to Justin. Cosine of 60 degrees.
It's going to be 1/2.
Short leg, very good. And Jacob, how about sine of 45 degrees?
√2/2.
Correct. Okay, great. So when we simplify and combine like terms, we have √6/4 minus √2/4. That's √6 minus √2 all divided by 4. And to check your answer, we need to be in degree mode. We put in sine of 15 degrees is 0.2588. Our answer is also 0.2588 ... So it does check out. Always check the instructions to see if they want exact form or decimal approximation. Okay. So this next one is similar to what we've already tried. We'll just do it together. For 5 pi over 12, we may do a little bit of side work here. That's 2 pi over 12 plus 3 pi over 12, because 2 pi plus 3 pi is 5 pi. And these radian measures do simplify to unit circle values. Pi over 6 is on the unit circle, and pi over 4 is on the unit circle. Okay. So sine of 5 pi over 12 can be rewritten as sine of pi over 6 plus pi over 4. Step 1 is to rewrite your given degree or radian measure as a sum or difference of angles that are on the unit circle. Must be on the unit circle. Okay. Step 2, we're going to expand. Go down here. So the sine identity goes as follows. We go sine, cosine, cosine, sine. So I'll write that. Sine, cosine, cosine, sine. The plus or minus sign stays the same for our sine sandwich. We insert first, second, first, second. Okay. So pi over 6, that's 30 degrees. 30 degrees is long leg, short leg. Sine is short leg. Pi over 4 is the twin group. Both coordinates are √2/2. Pi over 6 is 30 degrees. Cosine is the long leg. Sine is the short leg. So cosine is long leg. And then pi over 4, twin group. Both x and y coordinates are √2/2. Okay, when we simplify, we get square root 2/4 plus square root 6/4. So that's going to be square root of 2 plus square root of 6 all divided by 4. Okay, so students, I want to make sure that we're able to convert our calculator from degree mode to radian mode. So go ahead and put your calculator in radian mode and tell me, what is the decimal approximation for sine of 5 pi over 12? Share it publicly, because at this point, especially before we move into chapter 4 later this week, we want to be able to go back and forth. Sometimes we're going to be putting in degree measures, other times radian measures. So this one, we would be in radian mode. Radian mode. And share publicly sine of 5 pi over 12. That's right. Very good. Okay, it should be 0.9659 ... Great. Okay, 0.96. So this is just to check your answer. When you put in your answer, it should be equivalent, and it is. So that means your answer checks out. If they just want a decimal approximation, then you don't need to follow the 3 steps. If they ask for exact answer, as they do in the instructions here, then you do need to follow the 3-step process to get the exact answer for the given trig function. Okay. When they already give you an expression in expanded form, you check to see, is it using the sine sandwich or the cosine expression? Cosine expression is cosine, cosine, sine, sine, sine. The sine sandwich is sine, cosine, cosine, sine. So this one is the sine sandwich, because we see sine, cosine, cosine, sine. Okay, sometimes we need to rearrange terms here before we get the identity. But here it's already in that order: sine, cosine, cosine, sine. And then we have first, second, first, second. So applying the identity from expanded form to the condensed form, we have sine of first plus second. Okay, for the sine identity, the plus or minus sign stays the same. The cosine identity, the plus or minus sign changes. Pay attention to those details. Okay, we need a common denominator. So the first fraction multiply top and bottom by 4. Second fraction multiply top and bottom by 3. We have sine of 7 pi over 12. Okay, so we'll recap right here that identity group 5, that was cosine of alpha. We'll do plus or minus beta. Identity group 7, sine of alpha plus or minus beta. So using the jingle cosine, we went cosine, cosine, change the sign, and then we had sine, sine. For the sandwich, sine starts with an S, sandwich starts with an S. So sandwich is sine, cosine, cosine, sine. And then we inserted first, second, first, second, first, second, first, second. Okay, moving on to number 8. The 8th group of identities is going to be the sum and difference for tangent. So number 5, number 7, number 8, those are the sum and difference for cosine, sine, and then now tangent. Cosine and sine are ones that, oh, go ahead, sorry.
Can you go a little bit up? I didn't get to finish reading. Thank you.
Great. So number 5 and number 7 are ones you want to store in a memory. You'll be using them in this class and beyond. Number 8 is not one you necessarily need to store in a memory.
I copied it.
Okay, great. Number 8 is not one we necessarily need to store in a memory. because we know that tangent is sine over cosine. So if we're asked to find tangent of any angle, we know that tangent is sine over cosine. So if we don't remember the sum and difference identities for tangent, that's okay because we can rewrite tangent as sine over cosine. And we do know the sum and difference identities for both sine and cosine. However, for this particular chapter, we want to memorize or learn all 10 groups of identities. And if we don't have it stored to memory, we have it on our 1 page of notes that we can use on exam 2. Okay. So I encourage you to be writing down all the identities in chapter 3 on 1 page for you to use as a reference guide. I've been encouraging us to do that. Okay. So since tangent isn't one necessarily we need to store to memory long term, there isn't a special jingle to it, but it's worth learning for this chapter. So tangent of alpha plus beta is tangent of alpha plus tangent of beta divided by 1 minus tangent of alpha tangent of beta. And then tangent of alpha minus beta, that's tangent of alpha minus tangent of beta, divided by 1 plus tangent of alpha tangent of beta. Okay. So if you don't have it stored to memory, remember you can put it on your reference page. So let's follow the 3-step process. Step 1, we rewrite the angle as a sum or difference of 2 unit circle angles. So the most obvious here is 75 degrees is 30 degrees plus 45 degrees. You could have actually done 120 degrees minus 45 degrees.
Professor, it doesn't matter what order you put it in though, correct?
No, yeah, addition is commutative, so the order doesn't matter. That's right. That means your answer might look a little different than mine, but it still could be equivalent because addition and multiplication are commutative. Okay. So let's go ahead and move on to step 2, applying the formula. So step 2 is apply the appropriate identity. This one is identity group number 8. Tangent of first plus second. That's tangent of first plus tangent of second divided by 1 minus tangent of first, tangent of second. Okay. So off to the side, why don't we figure out tangent of 30 degrees and tangent of 45 degrees? We're going to hear from, let's go to Miguel. So Miguel, at 30 degrees, what are the lengths of the legs? Very good. Long leg, short leg. So our y coordinate is short leg, 1/2. Our x coordinate is long leg, √3/2. Okay. When we have fraction divided by fraction, we do top fraction times reciprocal of bottom fraction. And after we rationalize 1 over √3, we get √3/3. That's right. Okay, let's hear from Juan. Juan, what is tangent of 45 degrees?
Oh, what?
That's right. 45 degrees is the twin group, √2/2 divided by √2/2. When the legs are the same length, the ratio of the vertical leg to horizontal leg will be 1. Okay. So let's apply that. Means we have tangent of 30 degrees is √3/3. Tangent of 45 degrees is 1. Okay. So there are going to be quite a few algebra steps we need to take care of here. When it says write your answer in simplified form or when you need to express your exact answer, we always need to rationalize the denominator. So let's do the work here. When you're working with fractions, you need a common denominator in order to add or subtract. So Stephanie, how can we rewrite 1 such that it has the common denominator of 3?
Rewrite it as 3/3.
That's right. So rewrite 1 as 3/3. Okay. Rewrite 1 as 3/3. Okay. Now we can move up here. Oops. So on top, this is root 3 plus 3/3. On the bottom, we have 3 minus root 3/3. Okay. When you have a fraction divided by a fraction, we do top fraction times reciprocal of bottom fraction. So this division sign here, we convert it to multiplication and we reciprocate the divisor. Fraction divided by fraction will be top fraction times reciprocal of bottom fraction. Anything divided by itself is 1. And then now we need to rationalize. When you have a square root in the denominator, if it's just 1 term, you multiply top and bottom by that square root. If it's 2 terms, we multiply top and bottom by conjugate. So conjugate of 3 minus root 3 is 3 plus root 3. So these are all algebra moves. What we're doing here is that when we have a square root in the denominator 1 term, multiply top and bottom by that square root. Square root in the denominator 2 terms, multiply top and bottom by conjugate of denominator. Let's see what we have here. So binomial times binomial, we distribute. First, outer, inner, last. On the bottom, same thing. First, outer, inner, last. Okay. So on top, it was 3 root 3 plus 3 plus 9 plus 3 root 3. On the bottom, we have 9 plus 3 root 3 minus 3 root 3 minus 3. So let's simplify here. 3 root 3 minus 3 root 3, that's 0. And then let's see on top here, 3 root 3 plus 3 root 3, that's going to be 6 root 3. 3 plus 9 is 12. And then on the bottom, 9 minus 3 is 6. Okay. 6 divided by 6 is 1. 12 divided by 6 is 2. So doing the algebra steps, our expression simplifies to square root of 3 plus 2. Take a look at those algebra steps to see if you have any questions. So we need to be persistent here. Okay. Okay. So when you have sine, cosine, tangent of an angle or radian measure not on the unit circle, see if you can follow the 3-step process to get the exact answer. Step 1, rewrite your angle as a sum or difference of unit circle angles. Step 2, apply the appropriate identity, number 5, 7, or 8. And then step 3 is going to be evaluate and simplify. The simplify sometimes is just one step, other times is multiple steps. We always want to make sure our answer does not have a square root in the denominator. That process is called rationalizing the denominator. Any questions with the trig or algebra steps here? Going back to Justin's question, the order for addition and multiplication does not matter. So if you answered 2 plus root 3, that's equivalent. You can check your answer by putting in, this time we need to be in degree mode. Okay, so students, switch over to degree mode and tell me, what is tangent of 75 degrees as a decimal approximation? That's right. Okay, good. 3.73. It says my internet connection is unstable, so it might be breaking up for a moment, but should be just temporary. Okay, students, is the connection okay? I got a message that my internet was unstable. Okay. So students, if you need me to repeat anything when the audio was cutting out, let me know. Take a screenshot of this page if needed. And yes, I saw that in degree mode, tangent of 75 degrees is 3.73. Our answer is also 3.73, so that matches. So let me repeat the full solution in case the audio was cutting out. Step 1, we rewrote 75 degrees as 30 degrees plus 45 degrees. Step 2, we applied the appropriate identity. This is the sum and difference identity for tangent. Step 4, that was step 2. Step 3, we are going to evaluate and simplify. So we used our unit circle knowledge to evaluate and our algebra skills to simplify. Always check that you have rationalized the denominator, meaning that your answer should not have a square root in the denominator. Because if the square root is in the denominator, that means you haven't finished the division step. Okay, so the next one, you're going to try for practice in your own time. It's very similar to what we've done. So we've practiced these problems with sine, cosine, and tangent, applying the sum and difference identities. So you're going to try this on your own, and you can check the answer should be negative root 3 minus 2. Okay, let's go ahead and move to the next. This is also a double star, which means you want to go back and review. You will see a problem similar on your quiz and or exam. So remember from yesterday, our double star problem was asking us to find the exact value of cosine alpha plus or minus beta. This time we want to find the exact value of sine alpha plus or minus beta. And our seatbelt step, which is the step we take before we start the problem, because we put the seatbelt on before we start the car, is to identify the quadrants. So on quizzes and exams, if your answer is missing a negative sign, that means that you put your answer not in the correct quadrant. So you have to check the quadrant. The plus or minus sign is very important because if your angle is not in quadrant 1, then some of the trig functions are going to be negative. So alpha being in quadrant 3, quad 3, sine, cosine, cosecant, secant are negative, tan, cotan are positive. Beta being in quadrant 4, let's see, quadrant 4 should be positive, negative. Sine, cosecant, tan, cotan are negative. Cosine and secant are positive. So we can tell by the plus or minus sign. Cosine is the x coordinate on the unit circle, sine is the y coordinate on the unit circle. And then tangent is y over x. So in quad 3, cosine and sine are negative, tangent is positive. The reciprocals follow the function. So if sine is negative, so is cosecant. If cosine is negative, so is secant. And then when tangent is positive, cotangent is also positive. Okay. So the sine identity for sine of alpha minus beta, that's the sandwich. That's going to be sine, cosine, cosine, sine. Insert first, second, first, second. Okay, so let's see what's given. We're given sine of alpha is negative 4/5. We're given that cosine of beta is 12 over 13. Now, in the notes, the numbers are a little more friendly here than what you may see on a quiz or exam, but the process is the same. To fill in these red boxes, we can use the Pythagorean identity or the triangle method. So use P. If you use the Pythagorean identity, remember, given sine of alpha, we can find cosine of alpha using Pythagorean identity. Given cosine of beta, we can find sine of beta. So this is the P method, or the new method we learned yesterday was called the triangle method, and I think a majority of students did prefer the triangle method. Okay. Okay, so students, go ahead and try this one on your own. Please put in a W for working. Once you get a final answer, send it to me in my DMs for participation. And remember that you always want to write your answer in simplified form. Okay, so try this one on your own. Share your answer with me in my DMs. You can use the Pythagorean identity to fill in the red boxes or the triangle method, either way. Once you have filled in the red boxes, then you're going to evaluate and simplify. Okay, great. Genesis, Stephanie, Justin, Juan, Khalid, Miguel, Hector, and Jacob are on task. Very good. I'm going to pause the recording while you're working, and then remember to send me a DM when you're finished.
Recording stopped. Recording in progress.
Okay, students, let's come together. So I'm seeing some correct answers, some that need us to check so we can discuss together. Okay, let's use the triangle method. When using the triangle method, we need to be aware of the quadrants. Well, really with either method. And so alpha is in quadrant 3, we'll circle that. And we're given that sine of alpha is negative 4/5. Okay. Okay, so we'll draw our triangle as such, our right triangle, and we'll put in the reference angle. Remember, alpha is in quadrant 3, so alpha is not an acute angle. The acute angle in the triangle is going to be in quad 1, so it's the reference angle. It's alpha prime. Okay. But sine of alpha being negative 4/5, we know in a right triangle, the ratio of opposite to hypotenuse is 4:5. And using the Pythagorean theorem, we can find the missing leg should be 3, because we know the Pythagorean triplet, 3, 4, 5. So given one leg is 4, the hypotenuse is 5, our missing leg is 3. Use Pythagorean theorem. Pythagorean theorem. Okay. Now that we have set up our reference triangle, we can find any trig function evaluated at alpha. So first we'll use the reference angle, that cosine evaluated at alpha prime. Using the triangle, I'll put off to the side here. So sine is opposite over hypotenuse, ka. Cosine is adjacent over hypotenuse, and then toa, tangent is opposite over adjacent. So cosine is adjacent over hypotenuse, that's 3/5. But since we are in quadrant 3, cosine is negative. So we'll write here. Cosine is negative in quad 3. In quad 3, both sine and cosine are negative because the x and y coordinates are both negative. Okay. Our beta value is in quadrant 4. So beta in quad 4. And in quadrant 4, x is positive, y is negative. Let's hear from Stephanie. Okay, so Stephanie, we're given that, let's see which one has beta. Cosine of beta is 12/13. So when we set up our reference triangle, adjacent to beta is 13, sorry. Cosine is adjacent over hypotenuse. So adjacent to beta prime is 12, hypotenuse is 13. Okay, so let's go to Stephanie. Stephanie, what is the missing side and how did you find that?
Using the Pythagorean theorem, the missing side is equal to 5.
That's right. So using the Pythagorean theorem, our missing side is 5. Okay. Okay, so we want to find sine of beta. We take sine of beta prime first. Okay, so sine of beta prime in our right triangle, it's opposite over hypotenuse, applying right triangle trig. So 5/13. But then to get sine of beta, we need to check the quadrant. Since we're in quadrant 4, cosine is positive, sine is negative. The y coordinate is negative in quadrant 4, which means your sine value is negative in quadrant 4. Okay. So sine is negative in quad 4. So you can see that the quadrants are going to determine whether the trig function is positive or negative. So we found those red boxes. We found that cosine of alpha is -3/5. Sine of beta is -5/13. So our sine of alpha minus beta is, let's see here, -48/60 minus, this is 15/60. Or sorry, the denominator should be 65. So it's -48/65 minus +15/65. -48 minus 15 is -63. So our final answer is -63/65. This one we wouldn't be able to check in the same way, because when you use the inverse trig function, it gives you an angle in the restriction, not necessarily in the quadrants given. So in order to check the answer, we would need to use chapter 4 skills, which we haven't learned yet. Okay, take a screenshot. Ask questions if there's any part that you don't understand for this double star problem. So please type in G if you're good to move forward. What you put in the chat is really helpful for me. Justin, after seeing the full solution, do you see?
Yeah, I was thinking it was in quadrant 4, but it was in quadrant 3.
Okay, yes. Yeah, so even if it's right there in the problem, rewrite when you have two different angles in different quadrants, write it down on your work so that you can go back and reference it. Okay. So yesterday we went in breakout rooms to try 3 proofs. Today we're also going to go in breakout rooms to do a couple proofs, because you will be seeing proofs on exam 2, free response, where you're going to have to show that one side is equivalent to the other side using identities, or you simplify both sides and show they simplify to the same expression. So right now we have 8 identities in our toolbox. And on your reference sheet, you should have the identities for reciprocal, tan, cotan, Pythagorean, even, odd. Sum and difference for cosine, cofunction, sum and difference for sine, sum and difference for tangent. So we have 8 groups of identities. In the last section of chapter 3, we're going to add 2 more to that list. Okay. So there's 2 proofs. When it says verify the following identity is true, that means you want to prove that the statement is true by method 1, starting with one side, transforming it to the other side. Method 2, simplifying both sides individually and showing they simplify to the same expression. So I think for these problems, we can use method 1. Start with one side. LHS is for left-hand side. RHS is for right-hand side. So start with one side. Use your identity list to help you transform that side to become the other side. And you may want to start working independently, but do share and collaborate with each other. So we'll spend a little bit of time in the breakout rooms. Okay. Okay. You might not be in exactly the same group. Okay. Okay, and Hector, before you go into the breakout room, stay in the main session with me for a moment. I'm going to stop the recording or pause the recording here.
Recording stopped.
Okay, I think did I do that right? Okay, yeah. Yeah, so Hector, stay in the main session so you can check in before you go into your breakout room. Students, any questions? In the breakout room, you're going to be working on these two proofs to finish up section 3.4. Then when we come back in the main session, we'll go through the full solution and you can check to make sure you have all the steps showing that one side is equivalent to the other side. If your group finishes early, take the time to work on homework. Always great to get some homework assignment problems done during class time. Okay, rooms are now open. Go ahead and join your groups.
So I started with the left side. I just expanded the top part and then it cancels out and then cosine over sine is cotangent and then sine over cosine is tangent.
Out.
Is that what you got?
You can go first.
What's that? Oh,
You can go first, bro. It's all right. I'll wait.
what's it? Oh, okay. Is that what you got, Miguel? Yeah, I separated it just like you would like a regular equation. And then the left side is huh? Yeah, I did sine of x cosine y over sine of x cosine y plus, so I separated it, cosine x over cosine or cosine x or sine y over sine x cosine y. And then the left side of that, it breaks down to just one because they cancel out. And then I separated the other two. So I put cosine x over sine x. That's a cotangent. And then the other side is sine over cosine, which is tangent. Sweet. Cool.
Just to clarify, you split it from like the sine cosine, like sine x cosine y. You split that, and then
Yeah, I can show
you
you.
you
I can
changed
show
the
you.
other one to cosine x and sine y.
Yeah, here, I'll show you.
I think I get you usually make like two fractions, right? And just kind of
Yeah, so
yeah, okay, I see what you did. Yeah, okay, that's smart.
cool. Anybody have any thoughts on number two? How'd you go about doing that? Oh, okay. Okay. Got you. Let me know.
I mean, the hint does say like 2x equals x plus x, so maybe we can do like the whole sum and difference thing for sine. But I don't know if it works because they're both the same. Because usually they have sine, then it's sine alpha plus beta, you know?
Wait, we can split up. Um, we can split it up. We can put sine two. Oh no, that's a plus. Oh no, x plus x. And then we'd expand it, I think.
And then can we like after we split it up, it would just make sine x times cosine x plus cosine x times sine x.
Oh, yeah, and then they would equal that side, I think. Oh, let me see. Let me expand it.
Yeah, because they're both the same value, so
Oh yeah, you're right.
you can just And they're multiplied, so yeah, that's why. That's why they're multiplied by 2 because they're adding each other
Mm-hmm.
and they're already multiplying by each other. So yeah.
Yeah, you're right.
We're done, right? We don't, there's nothing
Yeah, we're
else, right?
done.
Yeah. All right.
Well, the left side I put sine of x plus x, and then I expanded it using the which one did I do? The sum of differences. And then once you expand it, it's sine of x, cosine of x plus cosine of x and sine of x, which is technically the same thing. And then they combined to sine of x, cosine of x. Because they're the same thing because they have the same variable. Hey, Hector, are you good or you need help?
Right now, because I was with the professor, I'm
Yeah,
just
yeah.
doing it on myself.
If you need help, let me know.
Okay, thank you.
Hi, I'm checking in. Justin, thank you for reaching out. And so students, were you able to show one side is equivalent to the other?
Yeah, we already did both of them.
Okay, great. So as the other group is still working, we're going to take a couple more minutes. Open up your homework to look at some of the proofs. In the homework, it's going to guide and direct you through the steps, but we do want to practice with problems in the textbook showing one side is equivalent to the other because our exam will be free response. Okay, so keep working together. Thank you. Okay, let's go ahead and resume here.
Recording in progress.
Okay, so for these proofs, we start with one side, transform it to the other. One thing to be careful with, I've seen these mistakes previously on exam 2, is pay attention to the inputs. So for example, for number 1, we have the input x and y. If you have, let's say, sine squared of x plus cosine squared of y, if the inputs are different, then you wouldn't be able to use the Pythagorean identity. So just check for that. Okay. So we'll start with Justin. Justin, in your group discussion, what did you decide for the first step here?
Start on the left side,
Yes.
and then I use the sum of differences for the top,
Mm-hmm.
but then I split it. I put sine of x cosine of y over sine of x cosine of y plus cosine of x sine of y over sine of x cosine of y. And then the left part of that equation cancels out to 1. And then on the next part, I split it up again, the right side, which I put cosine of x over sine of x, and then sine of y over cosine of y, which both break down to the left side is cotangent, and then the right one is tangent.
Very good. So you're matching the inputs.
Mm-hmm.
Great. Okay, so let's write that out. That's correct. First, we'll expand the numerator using the sine identity. So that's sine, cosine, cosine, sine. Put in x, y, x, y. Remember, we said we need a common denominator in order to add fractions. At the same time, we can split it up. So if we have addition on top, we can break it apart and do first term divided by denominator plus second term divided by denominator. Keep track of the x's and y's. As Justin explained, the first term simplifies to 1. Anything divided by itself is 1. Oops. Anything divided by itself is 1. Okay. Let me move that down. And then here we have matching input. So cosine over sine is cotan. Sine over cosine is tan. So that's using the tan cotan identities. Okay. The first term simplifies to 1. Second term, c over s is cotan. Input is x. S over c is tan. Input is y. So the left side is equivalent to the right side, which means we've completed the proof. Okay, so group 2, if was your solution matching what Justin shared, just let me know in the chat. So Justin was in the first group. Group 2, did we have the same solution, something different? Any questions? Hector, Jacob, Justin, Khalid, and Miguel were part of group 1. So Esmeralda, Genesis, Jimmy, Juan, Stephanie, is your solution matching, yes or no? Please let me know in the chat. Yes, okay. Great, so let's go to Stephanie. For number 2, which side did you start on and how did you show one side is equivalent to the other?
So I started with the left-hand side, and I used the sum and difference properties of sine to rewrite sine 2x into sine of x plus x, which was then rewritten as sine of x, cosine of x, plus cosine x sine x.
That's right.
Which is then rewritten as 2 sine of x cosine x.
That's right, because you notice that both of these are apples. Sine times cosine is the same as cosine times sine. Yes, so when you have the same expression. So expression plus the same expression, that is 2 apples. So this is going to be 2 sine of x cosine of x. Very good. And that is your right-hand side. Thank you, Stephanie. Okay, remember that addition and multiplication are what we call commutative. So commutative means that 3 times 4 is equal to 4 times 3, or 3 plus 4 is equal to 4 plus 3, meaning if you change the order for multiplication and addition, it's still an equivalent expression. So when you see sine of x times cosine of x plus cosine of x times sine of x, that's 2 sine of x cosine of x. Now, if the second term had y instead of x, then they would no longer be like terms. But all the inputs are x, so here we have like terms we're able to combine. Apple plus apple is 2 apples. And this one actually transitions us nicely into identity group 9. Remember, we said there are 10 groups of identities. We've already learned the first 8. We're going to add number 9 and 10, and we'll have the complete list. Okay. Any questions as we wrap up 3.4? Maybe I should put up here for our reference. This was identity group 2, that cotangent is cosine over sine. Tangent is sine over cosine. And we know that tangent and cotan are reciprocals. So cotan is cosine over sine. Tan is sine over cosine. And then the inputs have to be matching. That's a reminder too that in the software, check that your input matches what they give you. So if the expression is in terms of alpha, your answer should be in terms of alpha. Those are details that we want to check for before we submit homework or quiz or exam. Okay, let me check the chat to see if there are any questions. Chapter 3 is one where oftentimes students share that they're able to follow all the steps during the lesson, but when they're doing the proofs on exams, they have difficulty. It really does take a lot of practice and reinforcement. And this is something you're going to see in trig and moving on to calculus, that you might have a general understanding in class, but without the practice and reinforcement, you won't be able to really learn and master the concepts. So go into the chapter 3 textbook. End of the chapter, there are practice problems. Practice the proofs. The nice thing about completing a proof is that you have an idea whether your solution is right or wrong, because if you're able to go from one side to the other side using identities, that means you have successfully completed the proof. If not, then we need to keep working on it. Okay, I don't see any questions. So this concludes the recording for section 3.4.